Right. What we are seeing is the widely seen quality of service around the globe. LLQ. This LLQ is nothing but the other popular queuing method, class-based weighted fair queue plus priority queue. So two popular queuing methods together forms low latency queue, LLQ. What are they? Priority queue, PQ, and class-based weighted fair queue. These two together, we call it as low latency queue. And this is what widely used best way of QoS. Now, this is a lab. In this lab, we have voice over IP traffic, we have HTTP traffic, we have FTP traffic, we have video traffic. So according to the real-time traffic observation, we would like to allocate some bandwidth for these type of traffics. We want to allocate some reasonable amount of bandwidth to this various type of traffic and apply to the interface where the traffic is sent and received. See how much of bandwidth I should allocate. That depends on your traffic. In the real time, you have to do some study on your traffic flow. Only then you will know how much I have to reserve. Here are some example numbers for HTTP. We want to give 1 meg of bandwidth, which is 1024 kilobits per second. For FTP, we want to give 512 kilobits per second. For video, we want to give 256 kilobits per second. But for voice, we want to put it in a priority queue. Listen carefully. This HTTP, FTP, video, they are not placed in priority queue. They are placed in class-based weighted fair queue. What is the weightage? If HTTP comes, I need to give more bandwidth. How much? 1024. If FTP comes, I need to give 512 kbps bandwidth. That is the weightage. If video comes, I have to give 256. Now for 1024, we will have a marking with either DSCP or TOS. We will have marking, but this is what the meaning we are going to give for the markings. But the voice over IP, we want to put it in a fixed queue, the queue that will never run out of bandwidth. The queue that will always forward the traffic without ceasing. All right, the HTTP FTP video will cease. When HTTP reaches 1024, cannot be given more than that in that per second. Per second, it is only 1024, fixed. Per second, it is only 512 for FTP, fixed. Likewise for video. But for voice over IP, we want to ensure that they never get dropped and enough of bandwidth is taken by voice over IP so that no packet will get dropped or delayed. That is what called as priority queue. That's a special queue. You can have only one priority queue and you can have many class of class-based weighted fair queue. In our example, you have three type of classification. So three queues, plus there will be also a default queue. So four queues, which is class-based weighted fair queue. And the only queue is PQ, which takes voice. And this queue has got always high priority, always guaranteed bandwidth, never stopped for any reason. So if you have a wire, in that wire you have various queues for various traffic. They all have limit, but this queue which you have on top, they don't have limit. So this is the wire, physical wire. That physical wire, you have this queue, which is PQ. Never delayed or stopped. But these queues, when they reach the limit, they cannot have more than that per second. So this PQ plus class-based weighted fair queue is what we call it as low latency queue. And this is the popular one. All other queuing methods are old methods. See the example here. In the class map, we match the protocol HTTP. This can be any name. Nothing wrong in giving the protocol name itself, but give it in capital so that those who do some verification, they will know. They will know what this protocol that you are trying to match. From the name itself, they will know. And voice over IP is a name, and protocol that voice over IP uses real-time protocol, RTP. FTP is a name, and if this FTP is a protocol. And RTSP is for video. So we have here various type of. So these class maps helps to match the incoming traffic. Match the incoming traffic. In the incoming traffic, if the traffic is RTSP, if the traffic is FTP, if the traffic is RTP, if the traffic is HTTP, it is just matching as the traffic enters. But action is not taken here. What is action? Allocating these bandwidths, giving this bandwidth. That is not still taken. This is just to match. That is why we call it as class map, classification map. Now it is the policy map where the action is taken. You see here, give any name. It need not to be LLQ. It can be any name. As I said, to make the reader easy, we have a name like this, but you can give any name. And we call the class which we created earlier. Here we created voice over IP with a protocol RTP. We are calling that under the policy map, we call that and we say priority queue. Priority means what? you are creating a priority queue of 512 kilobits, and this is a fixed tunnel. This tunnel will always have this 512, always 24/7, always 365 days, always. But these are like a round robin. HTTP gives this much, and then come FTP gives this much, other queues give this fair queue, and then again it will go to, there are chances of these traffics getting slight delay, but this never. This 512 thick pipe that you put, this is the whole physical interface. This pipe of 512 will never decrease or close. Sometimes this may close due to the congestion for a fraction of a second, for a microsecond, but this will never, right? So if HTTP is the traffic, you are setting bandwidth. This keyword is different. This is priority queue. Here you are setting bandwidth. Bandwidth is this much. What if more than that? Don't send. For FTP, bandwidth is this much. What if more than that? Don't send. This is the bandwidth. All right. And 512 for voice, after analyzing the traffic, you know very well that it will never go 512. Voice will never take more than 512. You are setting 512 like this. Voice will not need more than that. Voice packets are very tiny packets. So policy map is the place where we call all the class and we take action for the traffic. If it is RTP, real-time protocol, this much. If it is HTTP, this much. And for all the rest of the traffic, all the traffic which is not matched here, fair queue. Fair queue means it will dynamically create queues. It will dynamically create multiple queues and packet will be forwarded through that queues. Right, so there is a class map, there is a policy map. What is the third thing? Okay, I've already explained this. And what is the third thing? Third thing is you need to apply on the interface where you want to set this QoS. I want to apply it on the interface G01. That's where I want to apply. So when the traffic is going out of that port, the port should have voice in a PQ and all other in a class-based weighted fair queue. That's it. That's all. So easy. 3 steps. Classification, where you match the traffic. Policy, where you take actions. And then assigning the policy map. Service policy is the command where you assign the policy map by mentioning the direction, input or output. Right, that's it. Now, the verification commands are, you can go and see under the interface how much traffic have undergone the match. You can also see the class map and policy map that you create. This is the command which we always use to see the real-time QoS implementation. All right. So any question?